I'm Arnon, I'm the CEO of Canonic, and I'll talk today about the plant genetics from seed to product. I'll go through the challenges that we are facing, but first I will just briefly present our company and what we do. So this is a forward-looking statement since we're actually a subsidiary of a public company, so those legal statements needed to be told. In my agenda today, I would give an introduction about the company, then the scientific challenge that we have today, and I must say the presentation is a little bit scientific, but I'm sure that everyone would enjoy it. Then our approach to solve those scientific challenges. I would show one product use case and then talk a little bit about future prospects. So, as I said in the introduction section, I will briefly present the company before diving into the scientific part of the presentation. So, Canonic was established 3 years ago as a spin-off from Evogene, a world-leading computational biology company. Our company is focused on cannabis genetics, and we conduct advanced breeding with state-of-the-art computational tools. Canonic holds its own cannabis variety database featuring more than 1,500 lines in our database, and we've launched our first product in Israel just at the end of last year. Our distinct advantage is tackling market challenges through the plant genetics, and following the successful preclinical trials that we are conducting, we are also planned to launch products for specific medical indication. So, our vision at Canonic is to commercialize effective, precise, and stable medical cannabis products based on decoding the plant genetics for optimized therapeutic traits. So, this was a little bit about the company. Now let's go to the scientific challenge as we see it. In this section, the scientific challenge, I would try to highlight the state of the industry as it reflects from the R&D viewpoint. So on one side, we have this amazing plant, the cannabis plant, and this plant appears to produce thousands of different metabolites. Those are natural chemicals, cannabinoids, terpenes, flavonoids, and many other metabolites. Some of them are unique to cannabis, some of them are also present in many other plants. But most of you would agree that most of the chemicals, most of those compounds are still unknown, at least not till recent years. On the right hand, you can see the human cannabinoid system. This is a system where receptors react to specific cannabinoids in our body. We know CB1, CB2, and many other receptors, but many receptors in the endocannabinoid system, but still, this is probably the least investigated system in the human body today. So, on one side, we have the least investigated plant, on the other side, the least investigated human system, and we're trying to find the linkage and we're trying to develop medical products. So clearly, we have a very big challenge. In this slide, you can clearly see also the challenge of missing information. The average annual number of publications since the 1960s, and only in the last 10 years, we see publication about CBD, only some about THC, and almost none about other cannabinoids. So the gap in the number of publications and the know-how that we have today is also a relatively big challenge. Another challenge, it relies within the plant. So here you can actually see the average cannabinoid composition in the last 30 years. Most of the efforts onto the THC, very little efforts on other cannabinoids. So if this is our starting point, this is our starting material, that's another very big challenge. So we are lack of know-how, lack of research, and we are starting at a point where everyone pushed this plant for more and more THC. Now, This is what we call the farmer selection period. This farmer selection period is where cultivators around the world, either legal or illegal, push these plants with their own simple tools in their home, in their basements, and some cases in the academy. This farmer selection period, we can take it and learn from other crops, what happened there. So let's look on corn. Probably the #1 crop in the world today, right? This is how corn looked like a few hundred years ago, and this is what we grow today. So you see this significant gap, and looking on the yield that corn actually accumulated along the years, you can see the farmer selection period, the one that I mentioned before for cannabis, and the plant breeding starting when genomic science started to emerge. So the farmer selection period for corn ended in the 40s. There we started to learn about genetics. There we started to breed the plant. And we've gained more than 800 increase in yield for corn. So just imagine what we can do with cannabis today. But that took us 80 years. We don't have that much time, right? We're in the 21st century. We need things now. We need them fast. We need them to grow the best we can. But the good news is that we have today what we call the big data revolution. We have computational tools. We have algorithms. We have a lot of know-how, scientists, and so on. So the good news is that at least I believe that we can bridge this gap much, much faster than the 80 years needed for corn. So let's dive into our approach at Canonic. By the way, this is a picture taken from our greenhouse in Israel. On the right, this is our chief agronomist, Jonathan, and this is our nursery manager, Ido, working in our breeding facility back in Israel. So from the challenges I described, let's move to the genetic approach and the steps that we take in order to tackle some of those changes. We start with building our own genetic collection. Just a minute. We start with building our own genetic collection. Here you can see a phylogenetic tree taken from our genetic collection. So every line here is a different genetic variety. Overall, a few hundreds of them. As I said at the beginning, we've already identified and characterized 1,500 different lines of cannabis. So this is just a snapshot of the collection that we have at home. This specific collection was collected from various geographic origins, with different active compounds, of course, distinct plant structures, Sativa, Indica, Ruderalis, and their hybrids. And of course, it presents a very diverse genetic background. So we have the data, we have this collection. The next step is actually to characterize and to produce a very, very big data hub. And how do we do that? We cultivate this massive collection, almost 2,000 lines so far, and we generate layers of data to build our own proprietary database. Those layers include genomic data, phenotypic data, chemical data, and also in some places, preclinical data. In the genomic part, we have either whole genomes, SNPs, gene annotation, expression profiles, and so on. Of course, for the chemicals, we analyze cannabinoids, terpenes, and other metabolites in the plants. The morphology, phenology of all those plants is also very, very important. And in parallel, we conduct preclinical activity in order to characterize probably the most important trait of the cannabis plant, which is its therapeutic effects. From here, once we have all this data, let's see how we can actually utilize such a big database. This is just one example, and it talks about how to develop a genetic marker and why to develop a genetic marker. So genetic markers are specific regions in the plant genome that actually linked to a specific trait. So when you look on a specific phenotype, you see this bell-shaped, you would probably want to locate those plants that are here at the farmost end of the bell shape, because those are the best performing plants, but they would be only 1% of the population. In order to find them, you will need to screen thousands of plants, and that would take you a lot of time, a lot of money, a lot of resources. So when you have this kind of a database, you can actually apply computational analysis in order to find those specific genomic regions, what we call genetic markers. And this allows us to screen traits in the nursery. So once we do a breeding cycle, we have those genetic markers, we can go to the nursery, we can use techniques such as PCR, which everyone knows today due to COVID, thanks to COVID. So PCR was invented way before we know about COVID. This is the kind of techniques we use here in order to identify those specific lines that would hold the certain trait that we are looking for. And this is how we can screen tens of thousands of plants and identify those few hundreds that are relevant for our trait. Now, let's see an example. Here we've developed high THC genetic markers. You can see here the initial population with their average THC and the new hybrid population after a cycle of breeding and the selection with genetic markers. Here we got 20% increase in THC with the new population, and more important, 6 times more varieties that are over 20% THC. Okay, so this is just an example of a trait which is very popular today, like it or not. High THC is what our patients are looking for. So we've improved the target trait, we've improved the number of candidates for commercialization, therefore we can move forward and also develop a product based on those specific varieties. So here we worked on genetic markers. It should roll, come on. So the genetic markers are just one example, but taking all these breeding capabilities into this nice sphere can help us also utilize the computational power in order to match genetics of much more complex traits. So imagine that on one side you have this genetic population. Okay, each line characterized by its own specific variety. And on the other side, you have the cannabinoids and you have their specific symptoms, the one that they affect. Now, you really need the computational power in order to, come on, no. So it should show you how we superimpose this one on that one and actually select a specific region where we know that the genetics would work on the specific indication. So a use case on our products, by the way, those are 2 products that we have launched in Israel just 6 months ago. Those are up here, those are flower products, and these are new products that would be launched in Israel actually 2 weeks from today, oil products based on the same process. So if I start again with the story of a product, looking for specific genetics for specific indication, and I need to validate it, we work with preclinical systems. Here you can see dozens of different cannabis lines as an extract, and the way we tested them is working in vitro, in the lab, in order to find the active ones. This is just an example of one of our extracts. Here, G150, one of the extracts we tested for inflammation and for pain. And you can see here its anti-inflammatory effect in one trial and pain relief in another trial. Again, this is model systems, not clinical trials, but preclinical activity. More traits that we look for within the product, of course. We need to create this heat map in order to see traits within different varieties. And again, once a certain variety is therapeutically active, we can also check specific traits that are related either to consumer preference or other different agronomical traits. And again, in this case, G150, just an example of one product that we have developed and launched in Israel just a few months ago. This was all supported and still supported by a very nice clinical advisory board that we are working with in Israel and also outside of Israel. I won't go through all the names, but some of them are relatively known. And in terms of where we are today in the world, so yes, we are located in Israel. We have our own R&D facility in Israel. We also work with few cultivators in Israel that cultivate our varieties and manufacturers that pack our products. So our business model is actually to go all the way to the market with our brands. We are now cultivating also in Portugal. Some of those varieties that you've seen are cultivated over there as a variety trial with anticipation to get results toward the end of this year and start commercial cultivation in Portugal for the German and UK market. So for the Germans in the audience, you would enjoy our products probably a year from today. In this last slide, I would like to look into the future and see how we move from optimization to discovery of therapeutic traits. Probably this video wouldn't work as well. So today, most of the genetic companies are practically optimizing the current genetic variation. So you heard also in the lecture before me and probably in other lectures, cultivators taking genetic collection, trying to optimize and find what product or what variety would be their lead variety. I think we need to move from the optimization stage, which is looking on the genetic variation that we have, to the discovery phase, which means deciding what kind of traits we are looking for, what kind of genetic elements we would like to enhance, of course, with known and advanced breeding techniques in order to bring much better products and much better therapeutics and actually building a medical product out of the cannabis plant. So thank you for listening, and hope it was an interesting summary for a great day.